The question number 4, the component x component of resultant of several vector. We have 4 options: is equal to sum of x component of vector, may be smaller than sum of x components of vector, may be greater than sum of magnitudes of vector, may be equal to sum of magnitudes of vector. Very important question, very confusing question. Okay, so just we start here. Suppose this is x-axis and this is y-axis. Now here we in the question there are several vectors, so we can draw a vector like this one. Suppose this is vector a, so we can write here ax bx. So vector b can be write as ax bx. So the ax ay, see here ax ay, and we can write b is bx and by. So this is vector b. This is the coordinates, that is this is x component, y component, x component, y component. Okay, so can we write vector a as axi plus ayj, and vector b is equal to bxi plus byj. Okay, so in terms of unit vector, that is along x-axis and along y-axis. So we have a plus b, so we can write ax plus bxi, this is xi, plus ay plus byj. That is the addition of two vector. By definition, if we add two vector, then x component must be add and y component must be add. Now the first option is equal to the sum of x component of vector, x component of the resultant vector. So this is the resultant vector and x component of the resultant vector is the equal to sum of the x component of the vector. So option 1 is correct, x component. Okay, option 1 is correct. Now next option is maybe smaller than sum of x component of vector. No, this is not true. Okay, now again this is not smaller than, not smaller, so this is wrong because here ax plus bx. Okay, now may be greater than sum of magnitude of the vector. Here sum of magnitude of vector, so we can write here sum of magnitude of vector. So we have ax plus a vector and b vector. Sum of magnitude of vector is equal to, this is ax plus bx raised to the power 2 plus ay plus by raised to the power 2. This is the sum of the magnitude of the vector. May be greater than sum of magnitude of vector. Okay, so here sum of magnitude of vector, we are talking about not the sum of magnitude, magnitude of the sum of the vector. So this is not, this is mod of a plus mod of b. So this is equal to ax plus ax square plus bx square square root plus under root that is ay, that is a by, and this is ay square plus this is ax plus by square. So the option may be greater than sum of magnitude. Yes, it may be. Okay, because we have ax bx, ax plus bx. So we can write here this one, that is ax b x, see here ax bx is equal to, so ax bx is equal to mod of a plus mod of b, and this happen only when ay is equal to 0. See here ay is equal to 0 and by is equal to 0. if ay is equal to 0 and by is equal to 0, so vector b, modulus of vector b is 0, so ax bx is equal to mod of a. So this is very conceptual one. Now ax plus bx, okay, is always less than mod of a plus mod of b. When ax does not equal to 0, bx does not equal to 0, ay does not equal to 0, and by does not equal to 0. Okay, or either of one may be 0 but not simultaneously. So this is if we see here, this is the square, sum of a square and then square root. So this must be, and the sum of these twos are must be greater than ax square, because see here, ax square plus bx square root is always greater than ax, and under root bx square plus ay square plus by square is always greater than a, that is ax, this is ax and this is a y, by. Okay, so yes, ax plus bx. So we have right here ax plus bx. So sum is always less than, that is a plus mod of b always greater than ax plus bx. So here we have applied the inequality concept. Okay, so we will discuss more about inequality concept in mathematics. I hope you learn these concepts very easily. It is not so hard, but you must observe all the options very carefully. Have a nice day. Jai Hind.